I am Shivangi Karwa, and this video is part of my TA application for the CSE department at UCSD. So today I'm going to explain you the concept of hashing and hash tables. So let's get started. Hashing is a method which is used for storing and retrieving data at a constant time. It is basically a mapping technique using which we can map larger databases into larger data sets into small manageable indexes, chunks of data. So this process happens with the help of a hash function. So before diving into how hashing happens or what is a hash function, there are two main terminologies that are integral to hashing. The first one is a search key. So a search key is a unique identifier that are used to extract that particular records associated with that key in a database. So let's say I have a student database. So in a student database, we can assume that the key will be the roll number. So using roll number, we will be able to extract all the student information. Similarly, we can have different identifiers for different cases. Let's say we can have SSN or passport numbers to identify individuals. So that is what search key is. Now coming on to the hash table. Hash table is a data structure where we can store data in an array-like format. And each and every data value in that particular hash table is associated with an index, and which key will go to which index is determined using a hash function. So coming on to the hash function, in my screen, you can see that there are four main hash functions. The first one is kmod 10, kmod 9, and mid square, and the folding method. So let's get started with the kmod 10 function. So here k represents nothing but the key. So let's take an example, the first key that we have here as 24. So if we do 24 mod 10, here mod is the modulus of a function. So we will get an answer of 4. So here the value 4 is the index in the hash table where this particular key will be stored. So in the hash table, we can store 24 against index 4. Similarly, if we look for 52, 52 mod 10 will be 2. So we will store 52 at index 2. And then 91 will be stored at index 1. So that is how all the search keys are mapped using one of the hash functions. And this is at a constant time because we are not traversing through the entire list to look for the index where which we need to be stored. We need to store the value. We are determining it by using a formula. So similarly, kmod n also works the same way. Here n can be any variable, any constant number. And then the hash table will be created from 0 till n minus 1. And coming on to the next one, that is mid square. Here, let's take an example of 234. Let's say this is a key. So what mid square will do is it will square the mid value of that particular number, and whatever the value comes out of it, it will be the index of that particular key. So here we have 9. So 234 will be stored at index 9 in the hash table. And the last hash function is the folding method. This is generally used for larger numbers that needs to be stored in a limited space in the hash table. So let's say we have a bigger number. Let's say we have 1, 2, 3, 1. And we have a hash table that starts from 0 till 99. So in this case, what will happen? First, the algorithm will bifurcate the number, and then it will sum the bifurcated number. So in this case, we will have 43. So 43 is the index where which 1, 2, 3, 1 will be stored. So this is how a hash function is used. Different hash functions are used to store that particular search keys in a hash table. So now if we take an example of k mod 10, and if we have a new key, let's say 34. Now 34 mod 10 is also 4, but we already have a key here, 24, stored at index 4. So this case is called as a collision between keys. So to resolve that, we have two techniques. The first one is called chaining, and the other one is called open addressing. Chaining is also known as open hashing. And then what chaining does is it creates a linked list of all the entries, and then it associates that linked list of entries to that particular index. So all the entries in that particular linked list will be hashed into that particular index. So here, for example, we take the hash function as k mod 10, and we have three keys here. So 21 mod 10 will have 1. So 21 will be stored here. 32 will be stored at index 2. Now 31 again will be stored at index 1, but it will be stored as an entry in the linked list. So here we will create a new entry for the linked list, and then we will store that here in it. So this way there will be no conflict between the different hashing, the different keys. The other resolution technique is open addressing. So here we do not use any external data structure. We utilize our hash table. We store all the key in the hash table. So taking the same example of the keys, here 21 will be stored here, 32 will be stored at index 2, and then 31 will be now 31 cannot be stored at 1. So what one of these algorithms will be do, it will determine that which next space is empty. So let's say the third index is empty, so the 31 will be stored here. So this way all the keys can be accommodated in the same hash table. So this is how collision is resolved by using in hashing in the hash table. So some of the advantages of hashing are that it's very, very fast because it's doing all the insertions, deletions, and all the lookups at a constant time. The other one is that it's very, very efficient, which means that it is able to manage larger data sets into like smaller chunks. And now some of the applications for hashing includes database retrieval, caching, and then also file system management. So if we want to fetch any file very, very quickly, so we can use the concept of hashing. We use the concept of hashing to extract it. So that was all about hashing. Thank you so much.